So as we have discussed, right, what are caches and what are its type and what are the data structures. There are a few things that we should keep in mind, while deciding either we should implement cache into our application or not, because not in all cases it's not possible that in all cases cache will come out to be very performance efficient for our application. One of these scenarios in which our data is getting frequently changed. Okay, so for example, you have a very uniform query. The application is asking for a very uniform queries. It's not like a very particular set of data is very being asked very frequently. For example, there is query A and B and C and D and E, and we have a sample cache which has a single query storage. Okay, so what will happen, this is our database. A query will come for A and it will check A in this cache. It will not find it. It will go to database. Will return A and it will be stored in cache because it is the first query that came, and cache will assume that this will be asked again. Next next the second query comes as B. Now B is not there, so the data will be changed. So it will go to the database. Database will return B and A will be evicted because we have only one space, and we'll have B. Similarly, C, in the same case, C will come here, D, and then E, and then again A. So we have a very uniform form of data querying happening here, and you can see that every time whenever we are querying data, that database is being hit. So the actual use of cache here is not utilized. Okay, so the actual use of the cache here is not utilized. So that is why using cache here is not very. I'm sorry, someone came by, so I just lost my focus. Yeah, I was talking about. So the actual use of cache here is being not utilized because every query is being hit to the database itself. Okay, so yeah, this is one case. Second thing that you should keep in mind is called a expiration policy. Expiration policy. So in expiration policy, we should decide, or there should be a rule how long a data can reside inside a cache. So for example, we have a cache, okay, and we have no expiration policy implemented. And as I explained, right, we have a set of queries coming in, so it will store some set of data. But once the cache is full, we will not have the idea, which data to remove first and which data should take its place. Because definitely, when the data is changing, we should be able to remove. We should be able to decide, right, which data is being very frequently accessed, so it should stay in cache, and which data has become stale, or it has become, it has not been it has not been accessed from a very long time, so it should be removed. So there should be a very good expiration policy. There can be multiple. Again, it can be specially catered for the application or type of data you're dealing with. But yeah, you should think about expiration policy whenever you're trying to implement cache. Because if there is a data which resides for too long in the cache and it is not being used, so then definitely there is, again, it is associated with the cost. I'm sorry guys, there is someone always coming here and there. So it is associated with the cost, and definitely it will not help your application, and it will incur cost again and again. Point number 3 is consistency of data. Right, the data that is in this case, you can see the data that should be present in cache should be exactly matching with the data that is present in a database. So, for example, take some take example. There is some data that gets cached from your database into a cache. Okay, and by some other ways, or by some other areas, your database gets updated for the same set of data that is present in the cache with some other values. Now there is a data inconsistency between your database and cache. Okay, the data that is present in your cache is different from the data that is present in your database. So whenever someone will try to access your will query the data, they will get different results when they'll query the database and then cache. So this will cause data inconsistency, and this is not right. So every time we should plan. So whenever there is a change in database, either the cache should be updated, or the data should be wiped out or cleaned, in case to avoid data inconsistency issues. Okay. So yeah, this is point number 3. Point number 4 will be single point of failure. As in most cases, in most cases, what cache does is, cache acts as a middleware between our web servers and our database. Okay, sorry about that. So in case you just have one, for example, you might have multiple database instances spread across the world, but if you just have one instance of a cache, and in case the cache goes down, the overall functionality of your application will go down again. It will, just like the cases we discussed in database, and when we were studying about load balancers, how a single web server can act as a single point of failure, or a single instance of a database can act as a single point of failure. Similarly, just a single instance of a cache can also act as a single point of failure. This is not in all implementations, because in some cases what happens is that instead of a coupling between web servers and cache, there is in a lot of applications, what architecture, what they do is they have coupling between web servers and app and databases directly also. So in case cache fails, they can interact with the database itself, even those with slower speeds. But in microservices architecture, or in newer architectures, we generally prefer loose coupling. So in that cases, we put cache as a middleware. So in that case, this situation can arise, that this can act as a single point of failure. So generally, to avoid that, just like we have multiple instances of our databases and multiple web servers, we have multiple instances of our caches also. Generally, providers like Redis and Memcached, they have inbuilt, they have these services inbuilt. They have multiple copies of your caches spread across the regions or zone or globe, depending upon the type of the subscription you have. But yeah, if you are implementing your own cache, you can keep this in mind. The last point is, I think, is called eviction policy. So if you remember, we have talked about, right, expiration policy. Eviction policy is somehow related to this only, but in expiration policy, we were talking about data getting stale and deciding, if data gets too stale, what should we do with the data. So in eviction policy, we decide the same thing, but we decide, what kind of strategy will apply to remove that data. So generally, you might have heard about least recently used LRU caches. These are very common, and there is a whenever, for example, we have this cache and we have certain data items. Okay, so generally there is a timestamp attached to these particular these particular items, and whichever is the oldest item that has been that has not been used for a the longest time. For example, A was used 1 second ago, B was used 5 seconds ago, C was 10, and D was 20. Now a new data came, E, and we have to decide now which one of these two evac. So definitely has not been used for a very long time as compared to the other data items. So D will be evicted and E will take its place, and it will put a new timestamp in this place. So generally, eviction policy, we should think about eviction policy. A very strict eviction policy will, put our caches useless, because every time whenever new data will come, will evict some old data. So the purpose of, not hitting a database for any data will not be reached. So a very strict eviction policy is also very bad, and very loose eviction policy is also very bad. So yeah, this was eviction policy. I think that's all we can cover in cache in very basic terms. Yeah. Thank you very much.